here. Yeah. Yeah, so today we will have a very short briefing on the topic first. Okay, so do you play around with sharpening before? No? Oh, okay.
Only on
so
Photoshop.
Tuga, please unmute your mic first. Is Tuga there? Oh, okay, good. Okay, so let's see the handout here. Okay, so smoothing filter, also known as low pass filter. So I believe you learned some of the smoothing filter, like mean filter, median filter, yes?
Yes.
You remember? Okay, so on the other hand, we have sharpening filter, or we call it as high pass filter, which aims to enhance the edges to sharpen the blurry image. So this is your title. So you have to enhance the edges or sharpen the blurry image. Later we will conduct region growing. So I think you haven't touched this topic yet, right? Region growing.
Yeah, we did. Yeah.
Already?
Yeah.
Oh, okay. Maybe another group, they are not okay, not so focused to the class. Okay, to segment the knee cartilage and compare the result with the unsharpened image. So that means like this one. This is the original image. Okay, maybe if like this, can you see more clearer? Like this one is a bit blurred to its iris, and then this one will be like very sharpened. You can see the tiny line here. Okay, so this is what we known as sharpening. Okay, so your report will be given marks based on these steps. Okay, so first, get your 5 MR images from the drive. So it is available in the coding and the images file just now. And then, second step, you have to conduct unsharp masking. So have you come along with this one? Unsharp masking.
No, not yet. Not yet.
Not yet. Okay, I think this one is not covered in your syllabus, but this one is a very good tools for you to understand the sharpening. Okay, to sharpen the image. So unsharp masking is a very common technique that is used in your phone or computer photo editing tool. So like Adobe Photoshop. So they normally use unsharp masking to sharpen their image. So once you learn this one, you can just edit your images. Okay, let's say today you go out and then you have a very blurred image. So you can try to sharpen it with your algorithm. Okay. So third stage, edge detection before and after sharpening process. And then step 4, region growing to segment knee cartilage by selecting seed point. And then there will be hint here, and then fill the form as below. So something like this. This is the original image. This is the sharpened image. This is the edge detection before sharpening, edge detection after sharpening. That means this one is detected from original image. And then after is from the sharpened image. And then you should have the segmentation with region growing. So this one shall be something like your final segmentation. Okay, is it clear?
Yeah. Yes.
Okay, maybe the whole thing sounds quite complicated to you, right? There are a lot of things like seed point, maybe edge detection, and then unsharp masking. So don't worry too much. We will go one by one. So for this week, we will only do for unsharp masking. Okay, you can try with a lot of images. Not necessarily you have to use my own images. This is the project. You have to finish this one, but you can edit your own images with this algorithm as well. Okay, so okay, so let's have some hands-on. So do you familiar with mallet coding?
Yes.
Yeah, anyone is very advanced or everyone is Lanson not touching mallet before?
I think all of us have that. I'm from Canada. I have used MATLAB before a lot.
You have used a lot. Oh well.
Well,
okay.
Not for this, but this is new.
Okay. Not for image processing.
Exactly.
Okay. So now we have some demo session, and try to screenshot the coding here so that you can continue with your project later. Okay, so normally we start our first line of code with clear or, close or, and clear. Okay, Clear all is the step that we want to clear the variable in the word space here. We want to make sure there is no other thing to interrupt our coding. And then close all is another line of code to close all the background application. And CLC is the command to clear the command window here, to make it clear. Okay, so another tips here, every time you want to compile a code, please ensure that your image is in the same file with your coding file. Okay, let's say this one .m is the coding file. So make sure the image must be in the same file, because now I have put all your images in different files. So you try to merge them later. Okay, so let's say I want to process this eyeball blur PNG. So I just modify the name here, blur PNG, blur.png. Okay, so we try to run this one. Okay, so now you can see the variable I here. Variable I, that is the image. Okay, this is a very huge matrix. Okay, image is actually a very huge matrix. The size is 630 times 1200. So do anyone has any idea on what is this times 3 here?
Is it the RGB?
Anyone? Yes, RGB. So that means this image is a color image. All right. So let's continue. So maybe we can change it to grayscale. Okay. And then we try to show the original image. Okay. So while showing the image, the code you have to use I am show. That is the image show. And then changing the image to grayscale, we use RGB to gray. Okay, so let's run. Okay, so this is the grayscale image. Okay, so now you can see the eye here is still a color image because it got times 3. So for gray, after we have the color changes to grayscale, so there is no more times 3. Yeah, so this is a very little information for you to debug in. So while every time it says the dimension does not fit, that means there must be some error in your color changes. Okay. So for this case, okay, so we just directly sharpen the image. We directly sharpen the image. Okay, so this is the sharpened image here. So you can see the iris is more significant. Okay, so this is just an example. So now we want to start from your assignment. Oh, Nurul Huda is here. Okay. So this will be your file name. Okay, so we start from beginning again. Okay, so we read the ni file name. So try to see what is ni file. I am sure RGB. Oh yeah, okay. So when the error coming up like this, so you can see the RGB images of size m times n times 3. Okay, so that means there is some problem with the color space. Okay, so let's see here, the word space here. So we can see the image size is 3f4 times 3f4, but there is times 4. Okay, so normally the maximum dimension that we can process in MATLAB is times 3. That is the RGB. So because of this image is ni MR images, so it has another layer of information on the MRI slice. So we need to throw away that slice to make it a color image. So this is the line of code that you have to use. We are telling the computer we are using only channel 1 to channel 3. That is the RGB. Okay, so let's see. So there shall be no more error. The fourth layer is for the MRI scan. So it is telling the doctor which scan it belongs to. like, yeah,
information on the scan.
yeah, informative layer. So we have to remove that one. So now, after we remove, by telling the computer, I'm only interested in those 3 layers. So it is now 3F4 times 3F4 times 3. So this is now a color image. So I want to show the image. Yep. So this is the image. So it seems like to be like grayscale, but it is actually a color image. So for MATLAB, for your convenience, so we decide to use grayscale image because it is easier to be, yeah, for computer efficiency, because if you try to process in 3 layers, it takes more time. So we try to use grayscale. So grayscale, we change it to grayscale. That means we remove this 3 layer into 1 layer only. Okay. So now our image will be 3F4 times 3F4. So we can see the 3 layers are disappeared. Okay. So continue, we try to smooth the image. Okay, try to smooth the image with some of the filters. Okay. So this filter, we know it as average filter. Average, I believe you learned before, is mean filter. Okay. If you want to use median, you just type median. Okay. So they are very here. Okay. So if you want to find something, you just write, yeah, MATLAB F special. And then you can create predefined 2D filter. I think Python to graph. Okay. F spatial, so you can choose average, this Gaussian, Laplacian, log, motion, and these two I don't think they are not smoothing filter. So you can try play around with this one. So here we use average, and then this hash size means the window size. So if here is 3, that means it's 3 times 3. The window is 3 times 3, and then we are after we mention about the size of the filter, and then we try to use IM filter. So anyone has any idea on IM filter? How about like this one? Do you know the process of smoothing process? Yeah, it's blurring. How they do? Yeah, what is the process name while they are doing blurring effect? How would you blur the image? Okay, I want the term. Okay, the term is convolution. I believe you know this one, convolution. Yeah, okay. So they will have a very small 3 times 3 window, and then you try to convolve every pixel in the matrices. Still remember?
Yeah.
Okay. So try to, you can have some revision here. So IM filter is the convolution process, which map the gray. Gray is the grayscale image, that is the original image, with our window size, with our filter. So we try to match these two, and then it produce another image, which is smooth image. So let's see. Okay. So now you can see the original image and the smooth image. Original one and then smooth one. So you can see the original, there are a lot of noise here. So you can see a very like white dots, and then So this one is more like blurrer, but more noise remover. Okay. So another hint for you. So this one is the window size 3. 3 means 3 times 3. How about if I change to 7 times 7? What could you expect the image to be? Is to be clearer or blurrer? Which one? Clearer. Any other answer?
I think blur.
Okay. Imagine if the window is bigger, will the image be clearer or blurrer? Okay, this one is smoothing filter. If the window is bigger, Okay, so just now I heard someone say clearer. Okay, let's try. So now we are using 3 times 3, right? So we try to use 7 times 7, and then we try to see the result. So now the result, can you see this one become blurrer or clearer?
Blur.
Okay, blurrer than just now, right? Okay, remember this answer, and then we try to change the window. Okay, we try to change the window to 2 times 2. Okay, so you can see when the window is smaller, the image is actually clearer. Okay, when the window is larger, the smoothing effect is more enhanced lah. That means might be wipe out a lot of information here. Yeah, it may cause some of the loss of information. So your job here is to identify the best window size to get good noise remover, but with edges retained. Okay, that's your job, yeah? Okay, just try to knock down. And then after we smooth the image, we try to sharpen. That means we try to recover the details like edges and the boundaries here. So we use this one. Okay, so sharpen. Sharpen is the command that for Unsharp masking. So I is the original image. Oh, okay. I use that. Smooth. Okay, use back the smooth, and then smooth is the smooth image here. And then the amount of sharpening I set 2, which is the maximum 0 to 2, I choose 2. And then I show the image, I am sure sharpen, and then titled sharpen image. So let's run. Oh, okay, this one is too small. Okay, let's try with 5. Okay. So when you see the window is too big, actually the sharpen image, it does not have a very good result here, right?
Yeah.
Yeah. So your job is to identify the best window size. Of course, don't use 2. Maybe we use 3. Okay, just try play around with this one. 1, 2, 3. Okay. So this is quite an ideal image. Okay, original image, and then we have a smooth image that we want to remove some of the noises. Okay, and then we try to sharpen it again to get back the edges here. Yeah, this is your job. All right. So you can play around with your images that you taken. You took with your phone or even your camera. You can play around. So don't worry. That is the interesting part for image processing. Yeah. Okay. So another thing. So does that mean the amount bigger means a better sharpening effect? Hi. Not sure. Okay. Okay, sharpening, it is a stage to sharpen all the edges. So noises like a very small door, it could be sharpened also. So maybe we have amplification on noises. Okay, we might have this problem. So maybe you have to play around with this value also. So maybe you can try with 1. So let's see, 1 is something maybe less clearer, but maybe it could reduce the assistance of the noises. So you can play around with this value. All right. So have you copied down this code? Yeah, maybe I just copy and then paste in the chat box. Okay. So for this week, let's see. Yeah, for this week, you need to complete this one. Okay, so all of this data you have to keep in a copy, and then you can just compile it to be your final report letter. So try to understand all of this stage. So what you need to do is original image. You have 5 images in your Google Drive, and then you have smooth image. So please mention your window size. Like you can try from 2 to 7, and then you mention the best one. So why? Okay. So once you choose like this, the first image you choose 3. So maybe you continue with 3. No need to alter the window size along all of this image. You can just choose 1, and then you try to give justification why is the best. Okay. So for sharpen image, you have to have the amount of sharpening with better sharpening effect with best noise removal. So you have your task is to find the best, the best mixture of window size and also the sharpening amount. Okay, that's your task. And then second, you need to understand what is unsharp masking. So please Googling. Okay, Google. So Unsharp masking is something very interesting. You can try to understand, and then you can edit your photo with this one. I think your project shall be the most interesting one among the others. You are lucky.
Oh, nice.
Okay. Yeah. So you can try it with Unsharp masking. Yeah. So you try to Google it, and then you try to finish all of this inside a docs file. Okay, Microsoft docs file, document file. And then maybe, yeah, you just send to me for the next coaching session, and then we try to look through the answer. So all of this data, you need to keep a copy with yourself and make sure all the image are in TIFF format. Okay, please no JPEG, no PNG. Okay, no PNG, no, what is that? PNG, BMP. We want TIFF format because TIFF is a very complete format. Yeah, clear? Everyone clear? Yeah, I know maybe today is Friday, and then it's a very early morning. Okay. So any other question?
Just now in the PowerPoint, the documentation
The PowerPoint?
this one. We should document like everything that we tried, or just the best one.
Which one? You mean the
Like,
you can try, and then you try to put only one here. It's like 3 times 3. Okay, you just put 3 times 3, but you give justification. You give some reason why you choose that number. Maybe like window size. If window size is too small, there is very small smoothing effect. So if the window size is too big, and then it causes the blurring effect, maybe we lose all the details here. So you can just give some of the justification. Okay, and then sharpening image, you can just play around with the amount of the sharpening image. So we are looking forward to you to what is that? To try trial and error. Okay, we wish you to play around with all those values, and then so try to give a very short conclusion. Yep. Yes, you only need to put the result.
like the best, yeah.
Yeah, the best one. But you need to give justification. Is it all right?
Yeah.
Yeah. Okay. So any other question? No from me. Okay. So later, if you have any question, you can just WhatsApp me or email me. I will be both active from now. Yeah. So I think we end here. Is it all right?
Yes.
Yeah. Okay. So thank you very much.
Thank you.
Okay.